This episode is brought to you by Paraswap, the leading aggregator to find best prices across various DEXs. You'll hear more about them later in the show. All right, everyone. This is a really interesting episode of Empire. I think you're all going to enjoy it. We had the three founders of Scroll, which is one of the least known but most innovative companies in crypto. They're working on zk rollups. Santi and I have just been talking a lot about what we want with the show. And one thing that's really important to us is we obviously want to bring you the big names. We're recording an episode with Olaf Carlson Wee later this week. We've got Kevin O'Leary, who came on the show. We have Vance and Michael from Framework. We want to bring you the big names, but we also want to get really into the weeds of what is coming, not just in a month from now, but in 6 to 12 months from now. These episodes are going to be a little more technical than you're used to. It might be with names that you've never even heard of, but this is the first one of those episodes. It's with Scroll. They came out of kind of beta and hiding for like a year, and they were just heads down building. It's PhD folks. It's people who've worked on machine learning and AI at Amazon. They're absolutely brilliant. They just raised their Series A, $30 million from Bain. I know Santi's an investor as well. And because of who Santi invests in, and just I think because of the show and because of Blockworks, we have access to some of these names, and we want to put them in front of you guys. So I hope you guys enjoy this. And Santi, I'm curious to get your take. What did you think of this episode?
I think this is sort of gets a peek into what I do on day to day, which is not just podcasting, but it really is meeting people that, from all kinds of walks, super smart people you've never heard of, but are doing incredible research. And there's a number of things that I get excited about when I first met them. These people, Sandy's come from a pretty successful venture fund. She was an entrepreneur before that. One of the other founders is at AWS in their AI team. And another founder is, pursuing his PhD and doing really cutting edge cryptography research. And so to me, it's always really exciting to see that because I think it speaks to Web3, and the primary thing that I get excited about, whether we're in a bull market or bear market, I always look at where are the clusters of human capital, and especially smart people want to work on very difficult problems. And we've heard Vitalik was talking about scalability since day one. And he's been pretty vocal around zk, like zero knowledge proofs are perhaps one of the most fascinating things that have been talked about over the years. It's been very theoretical, but I think we're one step closer, and it feels like we're, a year or two away from actually seeing like really efficient, practical implementations of this fascinating technology. And so it's great. I mean, the other element that I love is, it's a team that's primarily based in China. So I've always kind of been annoyed to some extent that I haven't seen that many Chinese projects. And I think it's by virtue that I'm not Chinese, I'm not in the ground. And for anyone listening, we had a great episode with Jason, who's based there and investing heavily. And so I think this is going to be a great episode, because I think you'll be hearing more and more about Scroll and what they're doing over time, which it's not to say that it's a winner-take-all L2 market. I think there will be multiple versions and implementations of them. But I think zero-knowledge proofs credibly really take us to like supporting billions of users. I'm going to go on a limb saying billions, but I think this is why this episode is important to get a better understanding of can Ethereum scale, which continues to be a recurring theme, especially with these as more applications get built and they just congest the block space and it becomes really expensive for users. But Scroll and other type of versions can take us there.
Yeah. Like you mentioned, Vitalik said in the medium to long term, zk rollups will win out in all use cases as zkSync technology improves, and Scroll's really pushing the boundaries of just scaling in zk tech with their zkEVM rollup. And so we hope you enjoy. You'll hear from three people here. So Sandy is one of the co-founders. She was previously a partner at Fission Capital, which is a crypto-focused investment fund. Haichen leads engineering. He was previously a senior applied scientist for the AWS AI team. And Zhang is now on leave, actually from he was getting his PhD at NYU. So they're absolutely brilliant. It becomes a pretty technical conversation. Santi kept with them pretty well, I'd say. Santi led most of this one, but yeah, we hope you enjoy it. If you enjoy it, DM me, DM Santiago, follow our account on on Twitter, and just let us know if you like this. If you don't like it, Santi's getting on Instagram now. So anyways, without further ado, enjoy the show.
Thanks, everyone. for the benefit of everyone, just give us a very basic explanation of what is Scroll.
Yeah, sure. So Scroll is a zkEVM project, and we're building something what we call native zkEVM, and striving for full EVM equivalency. And we're trying to deliver exactly the same experience on ETH L1 in a zk setup, so in a much faster and more efficient way.
And you know, I might be familiar with this. Jason might be familiar with this. But we want to peel it back for a lot of the audience. Like, what exactly is, when you say what is zk? Why is it so important and interesting for scalability purposes?
Yeah, maybe I can just quickly introduce like what is zk. So zero knowledge proof is basically it's a crypto primitive, which for instead of re-executing the computation itself, you can the one who executes this computation can mathematically generate a proof, which is very distinct. For example, it's for a very large computation that your proof may be just kilobytes, and you can verify this proof very, very efficiently. And verifying this proof is equivalent to re-execution of this computation. So basically, you can get your result in a verifiable manner. Like you get your result and you get the proof. And after verifying the proof, this result is exactly the result after you're executing this program. And because of this very nice verifiability, like it can fit greatly into this blockchain space, because blockchain needs publicly verifiability. For example, like if you broadcast a transaction in a blockchain layer one, every node after receiving this transaction or receiving this block need to re-execute all those computations inside, and this is very inefficient, right? Because you have that much redundancy, and the more nodes you have, the more decentralized you have, the more computation you need to do. So it's very inefficient to do that. And so the idea behind zkRollup is that we can leverage this stickiness of zk-SNARK or zero knowledge proof to compress this large computation off chain, and then on chain you just need to verify this proof. So the basic workflow is that you can, instead of sending all the transactions to a layer one network, you send that to a centralized layer two node. And this layer two node will generate layer two blocks. And for each block, it will generate some proof proving that all the transactions inside this block is correct. And then it will submit this proof on chain, and this proof will be verified by some on-chain smart contract. And so it's mathematically equivalent to re-execution of all those initial transactions. And then after it's got verified, like it means like it's already included. So this can massively include the throughput of Ethereum, and also like for each transaction, the gas fee will be amortized, because it will only be the verification fee and like amortized over like maybe 1,000 transaction included in this proof. So hope that can.
That's a good to understand. Maybe to start, like folks might be familiar with rollups. We talk about like optimism and arbitrum. These are some implementations of types of rollups. How does Scroll actually work, and how does it compare against something like optimism or arbitrum?
Yeah. So basically, if you are like so there are basically two categories for layer two. One is optimistic rollup, and the other is zkRollup, right? So they basically all like the high level workflow is pretty similar. Like you send the transaction to a layer two node, and it will generate some proof in some format and submit this proof on chain. But the difference is that zkRollup relies on zero knowledge proof. Basically, it's a validity proof, which means after you if you can generate the proof, which means those computations are already correct. Because if they are incorrect, or you insert some bad transaction, you can't just generate the proof, because it's your computation is not correct. So as far as you can generate that, it means the computation is correct. So it's basically only relies on math and crypto. But for optimistic rollup, they rely on a different proof scheme. It's called fraud proof. Basically, it's more like some economic challenge game, which basically the idea is that you can submit your result on chain, and because you also upload your raw data on chain, so everyone who seeing this transaction, they can re-execute this transaction on their local machine, and they can say whether we get the same result or not. If we don't get the same result, which means the one who uploads the result is fake, or like there are some bad transactions, and I can challenge this result. And then they went into some challenge period, and they do multiple rounds of such challenge game, and then like finally they just like makes all the challenge into just one step, and then on chain you will execute this step and know like who is correct or who is wrong, and then punish some party. So that's also the reason, because your multi-round interaction or this challenge game takes a very long time. So that's why like you need a longer time for withdrawing from layer 2 to layer 1 in optimistic rollup. So basically it's two different assumptions. And so but there are more like in among like optimistic rollup, there is Arbitrum and optimism. And in zk rollup there are like a lot of players like zkSync, Starkware, and us, and
Right. Maybe zk rollups have been sort of all the rage, and like with true academics, like it is kind of like the most ambitious. And when even I remember talking to like the Arbitrum guys, like I feel like most people agree that zk rollups are kind of the way of the future to achieve true scalability, because optimistic rollups kind of have a limitation at some point. But it's always been like the tech is super fascinating, but like computationally it's very difficult to actually get there. And so can you just give us I've been hearing about zk rollups since forever, like like talking to Zuko and a lot of like the leading cryptographers like are really fascinated by this, but it's been it has felt like it's been slow at times. But obviously a lot of people might not appreciate all the research, especially in academia, that's been going on in this field for a long time. I know you guys come from academia, so can you walk us through kind of like what has been the evolution of zero knowledge proofs? How is this moment in time different than perhaps 2018 now? Like how far have we come in the state of zk rollup research, and how close are we in actually seeing efficient implementations of zk rollups?
Yeah, that's a very good question. So basically, like back in 2018, as you said, it's zero knowledge proof is not as famous as it is right now. So the most used library is libsnark built by Zcash team, and the most famous application is still Zcash, where you can use zero knowledge proof to protect your privacy, and you can make some sharded transactions, and which is really cool. And then like I think the biggest breakthrough happens in 2019. It's actually the second half year of 2019, where there are a lot of new protocols coming out. And the biggest breakthrough, I think, during that time is the appearance or the discovery of polynomial commitment. So basically, polynomial commitment is a crypto primitive, which is actually the paper happened like 10 years ago, but you're like in 2019, like cryptographers, ZK cryptographers find that it can greatly reduce the overhead of protocols. And some other stuff which also makes this happen is that, as I mentioned, like proving overhead is very huge. But there are more and more research on ZK hardware acceleration. For example, we use work on some ASIC and IPGA acceleration for prover, and we also have the fastest GPU prover implementation. And those implementation can be like an order of magnitude faster than previous implementation. Mm-hmm. So like you also get very fast prover because the proving algorithm is highly parallelizable. And fourth is that you also got some more efficient construction for recursive proof. So the basic idea is that so for one program, if it's really large, you take a very long time to generate proof, right? But you can cut this program into several pieces, and you only need to generate proof for each piece. And then you can use one proof to verify multiple proofs and recursive miner, so that you can reduce the overhead for each piece. And then you get your final proof.
How do you differ from the different other implementations? And you were touching on this earlier, but like Starkware and zkSync.
Sure. Yeah. For Starkware and zkSync, we are very different. Like for example, Starkware is so they are also like we are all building some general purpose zk rollup. So it's basically in our zk rollup you can write smart contract and you can deploy. But we take different technical approaches and we have different compatibilities regarding to the EVM. For example, like Starkware, if you want to, they have a Starknet, which basically you can deploy a smart contract in Starknet. But if you want to develop a smart contract in Starkware and deploy that on Starknet, you need to use their domain-specific language called Carlo. So this language is designed for efficient execution in zero-knowledge proof. So it's a new language. It's pretty different from Solidity, from those traditional like smart contract developers. It's a totally new language with totally new features, and you have to re-implement everything there. And then like after you implement your program, their compiler will compile this down to their Carlo assembly code. And then like this Carlo assembly code can run on their defined ZK virtual machine. So it's a different, they also use a different virtual machine, which is different from Ethereum virtual machine. It's a totally new ZK virtual machine for efficient execution for ZK. For example, like you can generate proof more efficiently. And so that's Starkware. Like basically you need to use a new language and compile that down to their virtual machine and deploy there. And there is an external team who build some external compiler for them to be compatible with Solidity. So the idea is that Solidity is Turing complete, and their kernel is also Turing complete. So you can use some compiler to compile this Solidity to their kernel, like some readable kernel code, and then you can deploy that on Starknet. So it's somehow achieves some in some sense it achieves like language compatible, because you like for Solidity developer you can also compile, but it's like I think developers, if they really want to deploy on Starknet, they also need to be very familiar with the kernel, because it's very very insecure for developers who don't know what bytecode they are deploying there and what's a low level execution detail.
And to be absolutely clear and fair, you would have to learn Cairo to interact in Starkware or Starknet. You couldn't like use EVM, use a compiler, and then like you have to learn this language to deploy. And is that like a correct assumption?
So I think as Ian mentioned before, like there's a compiler built on third party like the called Warp, and they can compile some part of the Solidity into the Cairo to give you like a bootstrap, like how to program that. And then I think like if you want to go very deep, you still need to kind of like learn like what Cairo program means, and then you need to also make modification at that. And then I think at this point the Warp is not 100% compatible with the Solidity, with all like a Solidity compiler does. So you still need to manually look at like compare the generated code versus the original Solidity code.
And for zkSync, I think they take an approach which is more like EVM language compatible. And so their approach is that, so they also have their circuit language called Zinc. And you can write Zinc, which is to write some specific circuit. And they also have, because they also want to be compatible with Solidity. And so they want to be compatible with two languages. So they are using a compiler infrastructure called LVM. So this is a commonly used compiler infrastructure in like traditional like programming language or things like that. So the idea is that you can take any high-level language and compile down to some LVMIR, and then you can do some optimizations in this middle layer, and then like you can compile that down to different like microarchitecture. Like for example, like AMD and Intel, like they have different like ESA. So that's why like how like you can make different high-level language be compatible with different low-level VM structure. So they are reusing this, and so they basically have a compiler. They also have a compiler but built by themselves to compile Solidity or like low-level U, which is a Solidity IR, and then compile. But from very high level, you can just imagine it's Solidity to this LVM IR, and Zinc will also compile to this IR, and then they will like compile this IR down to their zkEVM bytecode. So they call this bytecode zkEVM bytecode, but it's different from Ethereum virtual machine because it's actually a different VM design. It just has this feature of being compatible with Solidity. So basically, it's still like compiler and compile down to a different bytecode or different like low-level style and run on a different virtual machine, which is different from EVM. So that's another like. So but the good thing is that they are more compatible with Solidity than Starkware. So I think they achieve like maybe 99% of Solidity and like things like that. And so it's more easier for developer to use that. And they have built some plugin for like in Hard Hat and for some other for developer to really easy to use that. But it's still like it's still not EVM, and yeah.
Got it.
I can also like add like a few some standpoint like the comparison between like us and then the zkSync and then Starkware. So I think one thing like you can take like from like a very more high level way to view this, like what your circuit trying to prove like so there's two level of things, like you can prove the Solidity language, like you can compile the language and then build like a different runtime. So like the Solidity code, like the smart contract they run on the Ethereum virtual machine is basically the runtime for the how you execute your smart contracts. But you can build like a different runtime in the zk circuits, and then you can prove that the Solidity code can be run correctly on your virtual machines on your runtime. That's like the kind of we call it like language level compatibility, and then that's like how the zkSync and Starkware is doing. So they design a different runtime like a virtual machines that's different from the Ethereum virtual machines. But on the other hand, like we're building directly like the we're taking the Ethereum virtual machine specs and then writing the circuit to prove the Ethereum virtual machine can be executed correctly. So we don't need to care about like how you compile your solidity into your Ethereum virtual machine's own instruction set. We just directly prove that all of the instruction executed in the Ethereum virtual machine can be correctly verified inside a circuit, inside the key circuit.
How difficult was this to put together? I mean, I think maybe if you can give us an understanding of all the work that's been done in the background, how the team came together, and how close are you when you say, you know, a fully kind of EVM, zkEVM, like I would assume that took years to build or is in the process of being built. Like, is it already complete? Maybe kind of walk us through the evolution of Scroll over, you know, last couple of months and maybe years.
Yeah, I think we have been building the zkEVM for about like around like 9 months so far, and then we're also working with a community, like not only us like building the zkEVM, also working with the some applied zkP team inside Ethereum Foundations, and then some other community members. That's because like that's the power of like building this like open source open source way, that you can have lots of people who are interested and who want to contribute to this, like they can build together. So I think so far so we're building like this. So we have like all of the high level designs of like how the zkEVM should work and how you should write the circuits to prove that. But we have like multiple circuits. Have like a main circuit that proving that state machine inside the Ethereum virtual machine can be executed correctly, and then all of the opcodes can be executed correctly. And there's other like sub-circuit merge circuit that can prove the memory and the stack, all of the RAM can be executed correctly. And then there'll be also some part like trying to prove the cat check, the hash function, the SHA-3 hash function can be executed correctly, etc. So I think that so far the progress is like we have, I think like around like the 70% of the opcodes can be already correctly verified and then proved inside the circuits. And then I think we're quite close to getting like something like really working. So for example, we can take like a ERC20 transfer execution trace, and then that can prove correctly inside the zkEVM so far.
That's great. And so if I have this right, Sandy, you were a partner at Fission Capital. You were sort of investing in blockchain. Haichen, you were previously at AWS, their AI team, I believe. And yeah, you were doing your PhD at NYU. So how did all of you guys come together and decide to build it? And who else is on the team? Where are you guys based? Just give us an understanding of how you work and how did it come together?
Sure. I think we met about a year and a half ago, kind of through mutual friends in the competitive math and Ethereum community. And once we got together, we started kind of as a group kind of brainstorming what were some of the highest impact stuff that like these like zk research could bring to the current kind of overall blockchain environment. And to us, like, you know, scaling is by far the biggest problem that exists in the space. And, you know, if we could solve that, that's easily like the biggest opportunity for the next decade. And so we started kind of toying around with some ideas, and, you know, based on some of Zhang Ye's research, we decided, you know, maybe we could have an edge in building something. And then it just all kind of spiraled and snowballed from there. I think up till this day, like fast forward, we have about 25 people now around the world, and almost everybody is connected through friends or mutual friends, through a kind of a common interest in research and building on the cutting edge of what's possible, and also just kind of through this like value alignment. I think everyone we've managed to gather so far are attracted to Scroll, not because of, you know, how high profile we are, and also not because of like, you know, how much resources we have, but it's more just like strongly aligned in terms of the interest in the project we were working on, and also this kind of common value about building in the open source and sharing the code with everybody, and kind of bringing this knowledge to everyone. I think that's part of our founding story, I think.
How do you think about like developing a moat when you are building truly in the open? Because other teams, you know, are closed source at the beginning, then decide to kind of progressively open source, and maybe for competitive reasons. But does this worry you that it could be a disadvantage for you guys if you're building out in the open?
I think part of our moat is the people we've gathered and the skill set and knowledge we have in-house. And that part is very difficult to replicate. And also the relationships we've built with the academic community. And I think for now, like the benefit of building in the open source far outweighs the cons. And I think with more people joining this community, and the faster we will go. And it's very difficult for someone who's kind of starting from a closed source setup to be able to move at the speed that we're doing.
And I also have some experience like working previously in the open source community. So I think that's like not different, very different from building like a whole like a protocols, which you're trying to build some trust with the like a large community. So like there's like the community which build the zkEVM, and then you can also like even expand that community to like the developers who like trying to build your new applications on your protocols. So I think like so having the open source, like you can starting from earning your trust, and then like starting from the beginning, and then you can have like more people who look at your code and who find like that piece of the technology is quite like the really good, and then also people can also verify that, can audit that. That's looking at the piece of code. And then also this is some way like you can attract those talented developers and researchers who like look at this piece like a code, and then they can be very interested and then come like the trying to contribute, and then even like that maybe can join you like and in the future. So I don't think like that's like a disadvantage of that. As you said before, like I think building the ecosystem is like the more of the success of the to define like a protocol, like a blockchain, a project. So that's like so we don't think like we worry a lot about like people forking your code, because like the building the community is like the more important pieces of things.
I want to get your guys' take on something. So we had Vance and Spencer from Framework on the podcast the other day, and they believe that every kind of scaled project will eventually migrate to their own rollup, right? To optimize the code for their application and end up adding utility to their own token. It seems like Scroll is on this kind of mission to have a general purpose rollup. Do you guys think that apps will end up using Scroll for their own rollup, or like what does that relationship look like in the future?
Maybe I can expand more. So they are definitely like, if you have special needs, you can have your specialized circuits and you can deploy your specialized zkRA. But, there are multiple problems inside this diagram, like for example, having too many application-specific zkRA. So the problem one is that you miss the most important thing, like in DeFi and in smart contracts, is composability. For example, like if you build something for DEX, you build something for lending protocol, like for each protocol, you build some new zkRA, but there is no composability, which means, you get some flash loan, you can't just, like spend that on any other application, because each proof will only generate for their own circuit execution. So it's very hard to have composability, like, between different zkRAs. So that's, very important. And also, like, as you said, like, you can have some customized, like, optimization for your program and write some customized circuits, but it's very hard, and like it needs strong expertise, it needs auditing, it takes you a lot more than just using one universal circuit. So that's another issue here. And the third is that, so even if we have built something that's very universal, we also plan to explore maybe adding more pre-compiled to our zkEVM ahead of Ethereum and support much more than just EVM, like at this stage. So that's our plan, like, yeah. And all
right, everyone, quick break from the show to share a big update from our friends at Paraswap, the best platform to stake, swap, trade, farm, and more. Paraswap just launched gas refunds. Based on how much you stake, you can now get up to 100% of your gas refunded on all of your swaps on Paraswap. This is huge. For anyone who has spent a lot of time in DeFi, or maybe is just starting out, you know how egregiously expensive the gas transactions can get. The gas fees are ridiculous at some points in time, and now you can get those entirely refunded on Paraswap. To participate, all you need to do is stake a minimum of 500 PSP. Big shout out to the Paraswap DAO for making these refunds possible. Really, it's tough to beat Paraswap right now. They give you the best prices. They save you money. You've got this gas refund if you stake PSP. They've got a smooth and really user-friendly interface, fast swapping. It's really everything that you'd want from a DeFi platform. If you don't use them already, check out Paraswap today. at paraswap.io. Now let's get back to the show.
On this point, oftentimes we talk about, the tech can be fascinating, can be superior, but there is still a lot of requirement from a BD standpoint to attract projects, to attract community. Obviously, you guys building an open source is very much aligned with the ethos of, I think, smart developers appreciate the true open source kind of ethos that you're taking. But talk to us a little bit more about how do you see the competitive landscape in an L2 environment? Obviously, we have Optimism, we have Arbitrum. We're going to have, Starkware there's a few implementations of Starkware. You have Immutable X. How do you see kind of broadly speaking, the L2 landscape evolving over the next couple of years? Where's your place there? And what is success? What is winning for you guys in this kind of, is it a race to become the best L2? Do you want to focus on particular applications? I'm curious kind of what goes into these internal discussions around kind of winning a market.
I think for the time being, we're just 100% focused on developing the kind of the best solution and the most developer friendly and the most user friendly solution. And that's going to occupy the bulk of our time until at least like the end of this year. In terms of ecosystem development, I think, we're hoping to attract value aligned like smart developers who recognize what we're doing, and they recognize that, being peer reviewed, it means we have hopefully a higher level of security guarantees. And then the third part is that, our kind of my personal hope is that, this L2 scaling will enable a lot of kind of novel and useful cases and expand beyond the current kind of prism of finance and GameFi, and enable kind of more high frequency transactions and activity on the blockchain. And I think some of the strategies we're thinking about are things that will kind of make onboarding a lot smoother, or kind of make the ease of access to L2 interaction a lot easier, and obviously kind of making the fees as low as possible from a technology standpoint. But we're hoping that all kinds of dApps will build on us. Like, hopefully this is going to be a kind of a copy and paste, kind of really easy experience to migrate, and the experience will be so smooth and seamless that everyone will want to come on.
Can you comment a little bit on how is it working with the Ethereum Foundation? Like, what does it mean to be like? I think they've lent their support to a number of other projects. I think including Optimism, for instance. But what kind of resources, what kind of experience have you had with the Ethereum Foundation?
So basically, like when we start Scroll, like our biggest motivation is that we want to build something general purpose, and we search then general purpose zkEVM because as I mentioned, like application specific has a lot of problem of composability and things like that, and also we want to decentralize our proof because we have done a lot of research related to zk hardware acceleration. So that's the two biggest thing. Like when we are building Scroll, it's like the EVM equivalent zkEVM. And also, like, we want to support decentralized proving process to attract even more members to make this faster and generate proof for us. So that's two biggest motivation. And I sent this draft to Barry Whitehead from Ethereum Foundation, who actually proposed zkEVM like years ago. And I was talking with him, and it happens to be that the case that he was also looking into this zkEVM stuff because one important roadmap or endgame for Ethereum is that it want to start zkSync everything. So the idea is that, for example, like for even on layer 1 Ethereum, like you get some block, you broadcast it into your network, and every node still need to re-execute a transaction inside this block to verify that it's correct. So if you directly use zkEVM in layer 1, which means it will totally change this, this workflow. So basically, for example, like you have some miner and you generate a block, and you will enforce this miner to generate proof for this block, and it will broadcast this necessary data for this block and this proof into their network. And every node, instead of re-execution of the transaction, they just need to verify the proof. So basically, it can scale layer 1 directly in layer 1. So that's their very ambitious goal, like take one existing Ethereum block and generate proof for that. And you can even build something which is MENA style, like, you can get one proof to prove the whole history for Ethereum, which is very exciting. And they are very interesting to look into this. But what we found more interesting is that we want to build some more efficient layer 2, which, we have our own account system. We generate proof of our layer 2 account and submit this proof on chain. So that's basically, zkEVM had two important applications. And we are pretty aligned with, because layer 2 is the infrastructure to scale Ethereum. So we really want to, push forward the development of Ethereum. And so that's, from that side, we are more value aligned. So this collaboration actually happened very organically. Like Barry asked whether you want to work on this, like collaborate or not. And we think, okay, so we definitely want to develop our circuit in an open source miner. And we, there are a lot of, brilliant brains behind Apply zkP team. And you can't, for now, like there are over like 20 people working on in this repo, in the open source miner. They have around like 10 people. We have around 10 people working with them. And so you can't imagine a company have 20 like very excellent and experienced zk researcher and working on the same problem. So it's a much stronger and much powerful from the community side, from the development side. Like so many great people are working on the same problem, and they have, it's even very hard to hire such a strong team, like, for a single company. So that's, it's really great. It's very nice to work with so many, nice collaborators there. And we talk, as Haichen mentioned, we have some weekly meeting to coordinate different process, and we collaborating on this, developing on this and or not, and things like that. So that's basically how this works. And so we are co-building this, but we are just leaning towards a more efficient layer 2 version. Yeah.
I want to ask you guys one last question on rollups before pivoting to talking about China for a second, which is, in your guys' minds, what is maybe for folks who are a little less technical like myself, what are one or two big things that you think get unlocked? If you guys are successful with Scroll, like how does the world look different? And how does the industry look different than what it looks like today? If you guys are successful. And maybe Sandy, if you want to start here, if I can put you on the spot.
Yeah, sure. I think the successful case in 10 years' time is, I think when, literally billions of people are interacting with layer 2s on a daily basis and using it on the back end of tools that they don't even kind of mentally register as, being blockchain based. I think that's the dream. I think we're already starting to see some novel applications where use cases are done where people are having like very, very frequent interactions with it, and it's kind of impacting their off-chain life. And we want to be a part of that to enable those things. And I think, a lot of businesses will be built on Web3, and we hope that will be built on layer 2. And I think up till now, because of the financial nature of everything that's been built so far, and part of that is due to the exorbitant fees of Ethereum up till today. And so once we unleash that possibility with a much cheaper and faster Ethereum, we will likely to see a lot more adoption in the developing world, and also a lot more tools and use cases that are like beyond finance and beyond like entertainment. But I think there's still obviously a huge amount to be built within the financial space and huge amount in the GameFi NFT space, and all of that will just be faster and better and cheaper. So I think we're kind of at the precipice of the kind of age where just before like Facebook and the FANG companies came about, it's impossible to envisage what would come and how these applications would manifest themselves. That requires a lot more experimentation and imagination and a lot more new talent coming into the space to make that happen. And I think we just want to play our role as an enabler and kind of facilitate and enable those like innovations to happen.
I love that. I think that's great. Haichen, would you add anything else there?
So I was thinking if we're successful, I was thinking if in the few years we can enable like the 10x or even higher, more throughput per second on the Ethereum, then I think that's kind of defines us as a success project for the Ethereum, I think. And then that's our goal. Also we can lower the transaction fee a lot, and then without sacrificing any security guarantee of the Ethereum itself, and then enabling more people to use the Ethereum, use the cryptocurrencies.
So just to make it very concrete of what you're saying, obviously recently you saw the ape land sale that kind of Guay went to 8,000 and obviously puts into question. Of course, they could have done some optimizations at the smart contract level, but still, it puts into question: can we scale? How many users in this? So say that Scroll is fully deployed and it's working. Like, how would this compare to, for instance, like Solana or some of the other kind of L1s that are claiming higher throughput and more efficiency and yada yada yada? But I'm curious, like, how many users, how many transactions? How do you measure like the scalability of Ethereum with Scroll?
Yeah, I think that's a good question. It's like the how. So I think like the first of all, like from if you compare the Ethereum versus the some solidity, like, so I think Ethereum has like a more a diversity of different applications, and then there's also like a lot of more innovations. I think it has like a stronger developer ecosystem there, and so there are like a more different applications there. But I think like but there's also a problem with the Ethereum is that it's not very user friendly. So not like user friendly, I mean like because like the transaction fee is pretty high, and then the waiting time, the throughput is not so good for the Ethereum. So I think those like a problem Ethereum Foundation, like they're also trying to solve that, and then that's like also what we are doing. So I think like if we say like we enable like higher throughput and then the lower transaction fee costs, I believe the whole ecosystem and the developer community of around Ethereum can come up with some more creative ways to build applications to enable like to bridge like more into the daily use cases, like not only like the financial applications. I was thinking that's like the one thing like I think with like more infrastructure building, like with more kind of the scalability of support higher frequency and then lower transaction cost. So there will be more and more different applications to come up.
We had Jason from Folius Ventures, who's also an investor in Scroll. He branched out, and his fund is solely focused on capturing the opportunity in China. And it's rare to find, I mean, perhaps Dragonfly, but most of the times, statistically speaking, China has a lot of really good developers and talent, I think, and engineers, at least in Web 2. You've had a lot of Chinese internet companies build a ton of value. Perhaps a more specific question is, like, we talk a lot about China, obviously, in the context of they've been at different times pro crypto and also against crypto. How is it to build a team? How comfortable are you to be there? And what's kind of your thesis of like, what is China's role in Web3? And I know there's a whole host of things, but just pick whatever you want to go, and then we can riff off of that.
Yeah. Well, maybe I can start with a kind of a first-person vantage point from our perspective, what it's like to build Scroll from the ground up, and what it's like to gather a team. I think one of the great things about kind of building in China today is that there are some great universities and producing fantastic math talents and computer science graduates every single year. And they're fairly concentrated, and it's easy to get access to that talent pool. So the minute we're working on something interesting, we start to attract like talent within like this core friendship group of kind of, like math champions. And that community unexpectedly translates very well in the US, where there's also a similar community, and similarly in like Ukraine and Eastern Europe. And that's how we managed to build, like kind of bootstrap the project and create the team that way. And I think from an application perspective, there's definitely a lot of kind of senior and trained talent in building very user-friendly products and being able to like adapt very well to the user feedback and environment. I think that part of the kind of startup science, or the setup of how to use a very user-friendly dApp, that's very, very kind of well entrenched within the developer community in China. In terms of the research community, the research community in China is relatively new to Web3, I would say. And unlike America, where there are so many like professor projects, I think a lot of the academics talent in China have not been so closely engaged with the Web3 world until recently. And part of our setup is that we're open source, and a lot of our researchers are still affiliated with academic institutions, and there are no problems with them sharing their learning and sharing their practical lessons with the wider world. And that reduces our kind of regulatory risk to a very large extent. And and we're very excited to work with so many kind of experienced talent from Web2 as well, who are looking to build in this to build in this environment. So I think the last few years has been has kind of been very kind to us in that sense.
Yeah. Would you say that like, are there any Web3 crypto protocols that have been started in China that you look up to? Because I know there's been a few very great researchers. I think one of them, which started Nervos, who was early on in Ethereum, like a core researcher, and then started off Nervos, which has had, I don't know, questionable success, I guess. And but I'm curious, like sometimes you need like a figurehead that you look up to in your local community. Is that true for you guys? Like, is there someone in China that you look up to, or is it just, or other projects that you want to emulate? Maybe it's Web2 companies in China that you kind of look at as kind of blueprints to emulate that success.
I haven't really thought about that question, mainly because the way we're set up and the way we're organizing our project is so different from anything we've seen. Obviously, there's been a huge amount of like startup success, and there are lots of products that we really, really admire in terms of how usable they are, such as TikTok. And I'm sure Ye and Haichen have their version of their kind of projects that they look up to. But there are so many to name. I think Little Red Book, and obviously Tencent, which people use every day. And we want to build a product that's in a similar sense, that's so easy to use that people don't even kind of think about it.
Yeah. Maybe a last question for you, Sandy. You were an investor and now a builder. What do you like more and why? I guess bear markets, you'd rather be a builder, and bull markets, you'd rather be an investor. And so right now, I guess you want to be a builder. I don't know. We're recording this while the world kind of is collapsing, which is kind of great and also comforting.
I think I was an entrepreneur before I was an investor. And having been investing for about 3 or 4 years, I really crave the kind of depth of knowledge that you're able to accumulate by working, like focusing on a singular project. And that was the kind of premises to which we started kind of, researching in the ZK space. And, and then having met Ye and Haichen, both being fantastic talents and just, complete geniuses in their respective fields, I think I just decided this was going to be the most interesting and kind of high impact role I can play in the wider kind of ecosystem and community.
Before we wrap it up, I'm curious if you could just comment on when can we expect to see kind of the first implementation or the beta for Squirrel? And I know timelines are very fungible in the space and hard to commit to. I'm not asking you to do that, but just give us a general kind of understanding of what are the next. Are we going to see Squirrel out in the wild in like the next 12 months? Is it going to be a couple of years? Just curious.
Yeah, I was thinking so we have like the different phases, like plans. I think the most recent plan we are having have some of the proof of concept, and then having like the people can see like how to do like the transfer using the zkRob, or even do like some like the Uniswap like the style the swap on the zkRob, and then that target that would be around like summer this year, so it'd be like not too far. But like afterwards, we also like need to do like the more like the increment more full-fledged zkEVM. That's like something like could be like the adding like in the future. And also we're also building like trying to decentralize things, like the starting like in phases. Like first we want to decentralize the proving networks, which helps you to generate the zk proofs, and then like the next one will be like the decentralize the sequencers, trying to make the whole things like also have like a community, like not removing the trust of like us like as alone, like, and then have like all have like decentralized things like to avoid some of the censorships and then removing the trust. So I have like different phases. I think I will be like the seeing in the next 1 to 2 years.
Okay, well, we'll have to hold you to that then. I'm kidding. Well, this is great, guys. I'm very happy that you came on and gave us for everyone out there, a little bit more familiarity with all the great work that's going behind the scenes. I don't know if there's any parting kind of comments or thoughts that you want to impress upon people. If not, it would be great to understand kind of where people can learn more about Scroll. I know that you had some really good resources on, in ETH Amsterdam, but I'm curious if there's anything else you want to add before we wrap it up.
I guess our website is the central reference point for all of our information, and I think one thing to stress is that Scroll is a really unique opportunity for people to live anywhere in the world, to participate in building zkEVM and literally work on the cutting edge of cryptography and engineering, and also possibly like community building and business development. I think that we're a blank slate, and it's very this is a hugely challenging project, and we're hoping that we'll have more kind of value aligned people kind of joining our midst.
Absolutely. Before we go, a lot of times people think that you need to be super technical to work in Web3, but it doesn't sound like that's always the case. Like there are plenty of opportunities to get involved, sounds like with you guys as well, even as a project that I would think of is perhaps on the more cutting edge of research and zk rollups. It's smart people want to work in difficult problems, but for everyone out there, I think it's just a reminder that you don't have to be an engineer to go work for a protocol, because you have plenty of other opportunities for people to co-work and help you guys on a number of fronts that are just not pure technical. So it's kind of refreshing to see. Well, great, guys. Really appreciate the time. I know it's late for you out there. I know you're in different parts of the world, but I really appreciate all of you coming on and wishing you all the success. And I'm sure we'll have to host you again once you make a little bit more progress and keep us updated on the state of zk rollups, which is fascinating and really mind-bending stuff.
Yeah. Also, thank you for having.
Thanks, San Diego. Thanks, Jason.
Yeah, absolutely.
Yeah. Thanks, everyone.